In this lecture of maxima and minima, we will understand the working rule for finding points of local maxima or points of local minima using the second order derivatives. In the lecture about concavity, we have discussed about the behavior of the second derivative of a function. We have seen that suppose f be twice differentiable on the open interval I, then if f double dash x is less than 0, then f is concave down on the interval. So, as shown in the figure, f is concave down. Again, if f double dash x is greater than 0, that is if the second derivative is positive, then f is concave up. With this concept, we have the following theorem on second derivative test. The theorem says, suppose f be twice differentiable on the open interval I at some point c belonging to the interval, then x is equal to c is a point of local maxima if f dash c is equal to 0 and f double dash c is less than 0. Then f of c is the local maximum value of f. That is, the first derivative must be 0 and the second derivative shows a negative sign, then we have the function a local maximum value and x equal to c will be the local maximum point. Secondly, x equal to c is a point of local minima if f dash c is equal to 0 and f double dash c is greater than 0. In that case, f of c is the local minimum value of f. However, the test fails if f dash c is equal to 0 and f double dash c is also equal to 0. In that case, we need to use the first derivative test. Therefore, we have the following working rule for finding points of local maxima or points of local minima using the second derivative test. The step 1 is find f dash x, that is, find the first derivative of the given function. Step 2 is solve f dash x is equal to 0. Let these values of x be a, b, c, etc. These are the candidates for maxima or minima. Step 3. Test the function for each one of these values. Say x is equal to c. Then step 4. Find f double dash x and put x equal to c to get f double dash c. That is, evaluate the second derivative of the function at this point x is equal to c. Now, depending on the sign of the second derivative, we have the following conclusions. If f double dash c is less than 0, then x equal to c is a local maximum. If f double dash c is greater than 0, then x equal to c is a local minimum. However, if f double dash c is equal to 0, then use the first derivative test. So, this is how we decide whether the point is a local maximum point or a local minimum point by using the second derivative test. Here is the summary of second derivative test. We have seen that if f double dash c is less than 0, then the point is a local maximum point. Then if f double dash c is greater than 0, then the point will be a local minimum point. However, if f double dash c is equal to 0, we use the first derivative test. We go back to the first derivative test. Therefore, we have this following note: the second derivative test fails if f dash c is equal to 0 and f double dash c is also equal to 0. Hence, we have discussed the working rule for the second derivative test.